3, 2, 1.
Salutations and welcome to Space Time Continues. My name is Mary Louise Davey. Let's get going to space.
LD, verify go for launch. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Liftoff at Falcon 9.
And we have main engine cutoff. Stage separation confirmed. And stage separation has been confirmed. And you can see the first stage there flipping back. Use the nitrogen thrusters. And
S1 boost back burn.
And the boost back burn of that first stage. Stage 1 just passed through transonic regime.
Landing burn startup.
And landing burn has hit startup, and we have ignition. See the landing legs at play in a few seconds. And we have touchdown. First stage has landed back at landing zone 1. It's another good day for us at SpaceX. It's a beautiful sight to see. That is the 4th landing of a Falcon 9 at landing zone 1.
Okay, so before I move on, let me revisit last episode's topics, or at least one of them, the black holes. Doesn't it figure that after I release the episode, that they find a second black hole that is floating around in our galaxy? And also, some black holes can apparently trap charged particles and create tornado-like jets that then shoot across the galaxy, kickstart a star birth. I mean, how cool is that? I fully plan on thinking this over, as it's kind of intriguing. So before I move on, let's review. Scientists now have evidence that a black hole about 100,000 times larger than the Sun is inhabiting the Milky Way, along with Sagittarius V4641. This discovery just might shed new light on the process of which galaxies grow. Now, granted, it's early on, and astronomers in Japan have collected the data, but it supports the black hole's existence. And while exploring a cloud of molecular gas located near the center of the Milky Way, in which gas moved at vastly different speeds, they studied the cloud, and the researchers saw that a clump of gas towards the center of the cloud that appeared to be moved around by massive gravitational forces. They said that, and well, you can read the astronomy report yourself. Black holes emit light of their own, no light of their own. So in order to find them, scientists often look for evidence in nearby gravitational disruptions, just FYI. Okay, so they went on and explained that located near the clump of gas was a source of radio waves, resembling those of Sagittarius A, the massive black hole that's at the center of our Milky Way. So, the similarities indicate the existence of a mid-sized black hole, the researchers say. And while scientists have the data supporting the evidence of supermassive and small black holes, they kind of lack evidence of the mid-sized variety. So now we have it. The black hole could have formed after a former core of a dwarf galaxy was absorbed by the Milky Way. Milky Way and other galaxies tend to swallow and eat up other smaller dwarf galaxies. They kind of cannibalize their smaller neighbors.
Galaxies are the building blocks of the universe. The giant galaxies we see today, even our own, were built up from many smaller galaxies. But construction isn't done yet. It continues even today. Full-grown galaxies approach and interact with each other. They may collide and eventually merge.
As the galaxies approach, the tug of gravity creates tides that distort their shapes. Stars and gas stream into new orbits. Sometimes they're completely ejected, trailing into the depths of intergalactic space.
Gas clouds compressed in the chaos light up with intense rounds of star formation.
Because stars create most of the chemical elements, such episodes have a profound effect on a galaxy's chemical makeup.
This infrared image of the entire sky shows 500 million stars. Most are in our galaxy.
Some are not. These are companion galaxies that orbit our Milky Way.
And some are in between.
In 1994, astronomers discovered that some of these stars actually belong to a different galaxy. It's called the Sagittarius Dwarf Elliptical, and the Milky Way is tearing it apart.
As the dwarf galaxy passes through the Milky Way's disk, gravitational tides stretch the dwarf stars into long streams that wrap around the galaxy's orbit.
For the dwarf, it's a fatal attraction.
For the Milky Way, it's but one of many similar events that shaped our home galaxy. But there's something much bigger headed our way.
M31, the Andromeda Galaxy. This is no dwarf. It's the Milky Way's biggest neighbor, of roughly the same size, mass, and type.
Astronomers say the crash will begin about 2 billion years from now.
This supercomputer simulation shows how the event may unfold over billions of years. The first pass distorts the two great spirals. Stars are tossed into the intergalactic night like sparks thrown from a campfire.
Our sun, complete with planets in tow, could be similarly ejected.
Each pass blurs the identities of each galaxy.
Eventually, Andromeda and the Milky Way will merge into a single entity some astronomers call Milkomeda.
How did the shape, structure, and chemical content of galaxies change over the sweep of cosmic history?
Deep surveys by the James Webb Space Telescope will capture the full panorama.
From the earliest dwarfs that formed to the familiar galaxies we see around us today.
A new subject, though it wasn't all that long ago, about 100 years ago, that we spoke of only one galaxy, or as it was called, stellar system, or maybe even the Milky Way, but never as a galaxy. Actually, the term galaxy was used almost to be a synonym for universe. Fast forward about 25 years later, Edwin Hubble arrived at Mount Wilson Observatory in California around 1919, and our view of the place in the universe changed drastically. Edwin Hubble's arrival at Mount Wilson Observatory in California in 1919, coincidentally, was roughly about the time that this 100-inch or 2.5-meter Hooker telescope, at the time the world's largest, was finished. So, with this grand new telescope, Hubble identified Cepheid variables, that's a kind of star that's used to determine the distance between galaxies, in several spiral nebulae, including the Andromeda, Triangulum. And from these, he was able to make observations that were able to prove without a doubt that these nebula were much too distant to be part of the Milky Way, and were, in fact, entire galaxies outside of our own. The year was around 1922, 1923, and obviously this was a major change. I mean, Hubble's findings changed the scientific view of the universe, not to mention the view of our own backyard. Sky watchers and everything. It just changed for everybody. So Hubble's discovery of the nebula outside of our galaxy helped pave the way for future astronomers, albeit Hubble was not exactly viewed nicely by his colleagues. Nonetheless, Hubble ended up publishing his findings on nebula, and later Hubble devised a system of classifying galaxies, grouping them according to their appearance in photographic images. He arranged the different groups of galaxies in what became known as the Hubble sequence. Today, near a century later, we're constantly bombarded with data on the immense diversity of the galaxies, to the extent that actually becomes difficult to write down a definition that distinguishes what one galaxy is from another and telling it all apart. I mean, it's kind of confusing. I mean, much of the data can be attributed to the Hubble telescope too, which is a really cool coincidence. You see, galaxies are the fundamental structure of the universe in which stars form. Theory currently holds that all galaxies are confined by the gravity of the dark matter that holds them together and permeates and surrounds them. But there's recent evidence that some of the galaxies may be dark matter free. It's also tempting to say that galaxies are where most of the ordinary matter in the universe resides. But recent X-ray observations have shown that there's actually more matter in the diffuse intergalactic gas than in the galaxies themselves. As a result, it's far easier to define what isn't a galaxy. Any object that can exist as a distinct unit, which excludes globular star clusters from galaxyhood. Dwarf galaxies are more luminous, typically by a factor of 100, than globular clusters, and are not dense. The distinction between dwarf and a normal galaxy is almost, but not completely, one of size. Dwarfs generally don't come brighter than a few billion solar luminosities. A few percent of that of the Milky Way. Qualifying a type of galaxy is also an issue of environment. A small galaxy may be dubbed a satellite if it's orbiting a larger system, but merely calling a field galaxy if it's not linked to a bigger galaxy, like the Milky Way or Andromeda. Satellites are often ingested by their larger cousins, and when this happens, the smaller galaxy loses its identity. This is the likely fate of many of the dwarf galaxies around the Milky Way, including the Sagittarius dwarf and the two Magellanic clouds. The larger of these clouds, however, technically isn't a dwarf at all, but the Magellanic Irregular, which tells you how arbitrary it is to put human labels on cosmic objects. According to Merriam-Webster, the definition of a galaxy: any of the very large groups of stars and associated matter that are found throughout the universe, or an assemblage of brilliant or notable persons or things, a galaxy of artists. So, obviously, the galaxy is a pretty big thing. Let's just look at our galaxy, the Milky Way, for the most part. It follows the rules. There are about hundreds of billions of stars, enough gas and dust to make a billion more stars, and at least 10 times as much dark matter as all the stars and gas put together. And it's all held together by gravity. Like most galaxies, about 2/3 of the known galaxies, the Milky Way has a spiral shape. At the center of the spiral, a lot of energy and occasionally vivid flares are being generated. Based on the immense gravity that would be required to explain the movement of the stars and the energy expelled, the astronomers conclude that the center of the Milky Way is a supermassive black hole, as we discussed last episode. This would be the black hole, well, Sagittarius 4641. Spiral is a common shape, but some galaxies have elliptical shapes. Others have rather unusual shapes, toothpicks or rings. The Hubble Ultra Deep Field, the HUDF, shows this diversity. Hubble observed a tiny patch of the sky, about 1/10 the diameter of the moon, for 1 million seconds, that's 11.6 days, and found 10,000 galaxies of all sizes, shapes, colors, and from the ground we can see very little in this spot, which is the constellation Fornax. Now, the formation after the Big Bang of the universe was composed of radiation, subatomic particles, and what happened next, well, that's up for debate. Did small particles slowly team up and gradually form stars and star clusters and eventually galaxies? Or did the universe first organize immense clumps of matter that later on subdivided into galaxies? Well, it's hard to say. Collisions. Well, the shapes of galaxies are often influenced by their neighbors, and often galaxies collide. The Milky Way itself is on a collision course with our nearest neighbor, the Andromeda Galaxy. Even though it's the same age as the Milky Way, Hubble observations reveal that the stars in Andromeda's halo are much younger than those in the Milky Way. From this and other evidence, astronomers infer that the Andromeda has already smashed into at least one and maybe several other galaxies. Recent discoveries date discovery, August 21st, 2017, a double discovery. We had NGC 178. August 10th, 2017, a starburst galaxy with the prospect of gravitational waves. The hockey stick galaxy, NGC 4656. In July was the galactic David and Goliath, NGC 1512 and NGC 1510. July 3rd was Hidden Galaxy, that's 342. July 21st, the massive dead disk, the galaxy that challenges the theories of galaxy evolution. June 9th, Cosmos, that's ESO 486-21. June, Hubble captures the galaxy of ultra-bright galaxies. In May, we had a close encounter with the IRAS. It's just galaxy after galaxy, and you see them floating by now. I'm showing them all to you. However, can you realize that we've made this many discoveries using the Hubble telescope? We've made this many just since January, and there's more than I'm saying, but I'm going to be showing you all of them. So, are you not amazed that we are just discovering so much about our universe? It's really incredible. So, obviously, if we're finding this much this much in a 6-month period, there's quite a bit we still don't know. So here's a picture of our galaxy, the Milky Way. It's a basic spiral. You see the 4 major arms from its disk and at least one spur, and then a newly discovered outer arm. The galactic center, which is located about 26,000 light years from Earth. And it contains at least one supermassive black hole, and maybe 2, because maybe that one that was discovered, possibly, you think. Crossed by a bar. Okay, the Milky Way got formed about 12 billion years ago. It's part of a group of maybe 50 galaxies called the Local Group. The Andromeda Galaxy is part of this group, as are numerous smaller galaxies, including Magellanic Clouds. The Local Group itself is part of a larger gathering of galaxies called the Virgo Supercluster of Galaxies. Milky Way Galaxy. Well, okay, you want to know about it, right? It's a barred spiral diameter is about 100,000 to 180,000 light years. Distance to the galactic center, about 27,000 light years. Mass, 80,000 to 1,500. The Sagittarius group is part of the local group. There are unique destinations in the Milky Way, and I'd really like to take you to see some of them. Say Globular Cluster, California Nebula, the 15,000 light years away from the Rosette Nebula, the Pleiades. There's just millions of things to see. There's 6 to 8 stars that can be seen by the naked eye from Earth. 10 billion years old, one of the oldest objects in the Milky Way. 26,000 light years away from Earth, with a luminosity of 100,000 solar luminosities. It's pretty good, huh? At least 100,000 stars belong to this cluster in the center. There are several young hot stars. I see a lot of hot stars myself, but that's on the Earth. The radiation of these stars ionizes the gas Horsehead Nebula, the most famous dark cloud in the sky. 1,500 light years from Earth. It's visible because it's situated in front of a bright emission nebula, the H Nebula, an open star cluster that's visible to the naked eye. 7,000 light years away from Earth, 11.7 billion years old, is the Chi Persei star cluster. That's visible to the naked eye. 7,000 light years away from Earth, 10.8 billion years old, is the Palomar 5, 70,000 light years away from Earth. Dumbbell Nebula, discovered in 1764 by Charles Messier, first ever found of the objects of the class of planetary nebulae. Ring Nebula, constellation Lyrica, 2,000 light years from Earth. For at least 20 some odd years or so, we've been discovering planets in our search for places perhaps we could move, maybe settle into a new place. But some of these places, like TRAPPIST-1 has, and it's several, I think it has 7 Earth-sized planets, 3 of which are in the habitable zone, the Goldilocks zone, if you will. A star only 8% as massive as our own sits in the system, a full 40 light years away. Now what I'm getting at is, we're looking at all these things, we're making all these fabulous discoveries, but they're that 40 light years away. Barnard Star. We know that one, right? So let's take a visit. Barnard Star is famous less for the planets it has than for the planets it doesn't have. Let me explain. The star, that's the 4th closest to us, has been the subject of a heated back and forth in the astronomy circles since the 1960s, basically wondering whether or not it has planets. The current answer is no. But for at least 10 years, following an official announcement by Peter van der Kamp in 1963, many people believed that the answer was a resounding yes, and that Barnard Star had 2 gas giants orbiting it. Well, van der Kamp never gave up on his claims, but Hubble observations show them to be impossible in the late 1990s. So here's the thing. Hubble didn't rule out Barnard Star could have planets, but it did rule out large planets at certain distances from the ancient sun. It's not out of question that a rocky world or Neptune-sized ice planet could live there. First exoplanet discovered, and holds the record for being the least massive, is an extrasolar planet approximately 2,300 light years away in the constellation Virgo. The planet is the innermost object orbiting the pulsar PSR BI 257 plus 12, i.e. a pulsar planet in a dead stellar system. It's about twice as massive as the Moon and is listed as the least massive planet known, including among the planets in the solar system. The planets in the system were discovered in 1992 by the tug that they gave on their home star. Pulsars are known as cosmic timekeepers, but something was making the beat of PSR BI 257 plus 12 just a little off. It was determined that the culprits were 2 planets, including this one. A third was later found. NASA, the first around Sun-like star 51 Pegasi b, while 51 Pegasi b wasn't the first planet discovered, it was the first confirmed planet around a Sun-like star. Even so, it was nothing like the planet we knew. This giant world completes a swift orbit of its star every few days. It kicked off the discovery of many hot Jupiters in orbit, even tighter than Mercury's. In 2015, the atmosphere of 51 Pegasus b was characterized in the visible spectrum, another first. Instead of just observing 51 Pegasus b's silhouette as it passed in front of its home star, we can study things such as the planet's actual mass or orbital inclination by looking at the visible light it throws off. This may seem like a small potato compared to how much we know about most of the planets in our own solar system, our own backyard, if you will. But when you're talking about exoplanet that's 50 light years away, this is valuable and fresh information. The oldest, PSR B162026b, the name PSR B162026b, like many of the other exoplanets, doesn't quite roll off the tongue, but this is the oldest planet known at somewhere around 12.7 billion years. That's a little younger than the universe itself. The ancient planet orbits both a pulsar and an ultra-dense white dwarf, itself another supernova remnant. The two stars orbit each other while the gas giant orbits around the gravitational center of those dense dance partners. Wikimedia Commons, the rocky Gliese 876d, it's only 15 light years away. It's small enough to be rocky, though far, far larger than Earth. But don't pack your bags just yet. Gliese 876d is a hell world. It spends a day in the shade, less than an Earth day. So it's apparent that we're not going to be moving to Gliese 876d anytime soon. However, the entire Gliese system 581, totally 3 planets in the habitable zone. And we are going to investigate that next episode because I want to discuss, remember when I said I wanted to do a generational ship? We're going to do a generational ship next episode, and we're going to go to the Gliese system, the Goldilocks zone. But before we say goodbye for this time, I want to tell you about this mysterious repeating radio signals that have been detected from outside of our galaxy. I can't really give you a lot of background on it, but we have heard this a couple years ago. We've gone back, there's been 10 blasts, all coming from the same direction that were detected last year. That's in May and June. Now, these FRBs, or fast radio bursts, normally you'll hear one and you'll hear, say, bop, 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 and you'll hear the same thing, bop, 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 the next time. There's a certain speed to either pulsars or anything like that that you're listening for. Well, these radio bursts have been a little bit different each time, and not at an interval that you would expect. Not an interval that you could say, okay, that keeps going off every 6 months doing the same sound, waits till the planet passes and then you hear it. It's a little different, and it's kind of bothering astronomers. Planetary items, star items that one would normally go to, well, neither's been the answer. So, they're really trying to figure out what's going on here, and the fact is they're unique. They've heard, besides the 10 between May and June, they heard another 16, all coming from this one area. So the brightness was different, the spectra was different from other FRBs. Researchers suggest the repeating bursts might actually be a whole new type of FRB. Or maybe someone's trying to contact us. Or maybe even one of our own, like the Voyager or something, is sending back data and we're just not listening. So it's odd. The timing of the discovery is rather interesting because we had just decided that we are close to understanding all there is about FRBs to know. And apparently it turns out we're not. So I'm hoping, and I think I mentioned this on an earlier episode that these were coming through, we're still getting these fast radio bursts. So hopefully we'll get to the bottom of this. Some episode soon I'll be able to report that Either it was a cause, a natural cause, and tell you what it was, or that it was a different kind of natural cause, and maybe somebody wanted to say hello. Anyway, I will see you next time on Space Time Continues. Let's play you out to Cassini and a fond farewell.